Today's lesson is going to cover law of sines. And as we look at the essential question, it will kind of direct us as to what is going to be covered. So how do you find all the missing angles and side lengths of a non-right triangle? And a non-right triangle is also known as an oblique triangle. So I'm going to highlight this right here. It's also known as an oblique triangle. How would you find those missing sides given certain information? Oh, and I'm sorry, you're not seeing my highlight because I have it on grayscale. So let me highlight it by underlining it so you'll be able to see what I'm talking about. So what I'm underlining here is what you will want to highlight on your paper. So non-right triangle is what an oblique triangle is. Now, what are you going to do when you are given certain information and you need to find the other missing pieces to that triangle? Well, what you are going to do is you are going to apply the law of sines. Okay? Now, how we go about doing that will be covered in example 1 and all the other examples as follows. But for Unit 6, you are going to see that you're going to have to apply law of sines and law of cosines for certain scenarios, and you will need to be able to differentiate between the two. So for now, we're going to focus on law of sines, and law of sines is only applied with the following classifications. So when you're given a triangle, if you are given two sides and an angle, or two angles and a side, whether it be this way or this way, you know right off the bat that you are going to apply the law of sines in order to solve your triangle. And right here in this rectangle is the formula for law of sines. You can use either these proportions or these proportions. It doesn't matter, just choose the one you are more comfortable with. Okay, so these are proportions. Now I need to remind you a couple of things from geometry before we dive right into this lesson. Okay, so first of all, again, as I said, an oblique triangle is a triangle that doesn't contain a right angle. All right, now to apply the law of sines, we must know at least 3 given variables. Okay, but here's what I want you to make sure you recall from geometry. All right, the first thing, let's recall here. Okay, capital letters represent angle measures. And for our chapter, our angle measures are going to be measured in degrees. So there's no need to be concerned about using radians. We are solely going to stick to degrees. Lowercase letters represent the length of sides. Okay. So wrapping this up in a sketch, I want us in the space provided to the left here, draw an oblique triangle. Doesn't matter what shape you want to draw it in, as far as you don't have to draw it exactly as I do, but draw one that's oblique, and I need you to label the vertices with the capital letters M, N, and O. Okay, for instance, M, N, and O. Now what I want you guys to notice is these capital letters represent the measurement of these angles right here. And these angles can be measured in degrees or in radians, but specifically Unit 6, we're focusing on degrees. Now, when you are labeling the sides, what you do is you take the angle and look at its corresponding side, and the corresponding side is always across from that angle, and you label it with the lowercase letter. So if I keep doing that for all of my vertices, I can find the corresponding sides. And this right here will be a lowercase o. Okay, so keep that in mind when you are required to have to sketch certain things. Okay, but in example 1, a sketch is already provided for us. So let's dive into this problem. I want you to notice that, and I'm going to use my pencil here to highlight since I have it on grayscale on my recording. I've been given this measurement, I've been given this measurement, and this measurement. Okay, but what exactly am I measuring? Well, this length, this 12, sorry, is measuring the length of this side. So I'm going to label it as an S for side length. These two numbers have units of degrees. They are giving us the measurement of angle A and angle C. So I am going to put an A for angle, measurement being given. And why am I asking you to make note of what is being given? Because when you look at what's being given, angle, angle, side, you can automatically deduce that you are going to use law of sines in solving your triangle. Because in order to apply law of sines, you have to end up with one of these three classifications. And angle, angle, side is this one right here. So let's do exactly what is being asked. So solve the triangle just means find all the missing values. So what I always do is I label in one column all my angle measures. So my capital letters will go first, and in this triangle they're labeling our vertices with capitals A, B, and C. And angle A was given, angle B was not given, and angle C was given. And right next to it, I will create a column for lowercase letters. And the 12 is across from angle C. So that's the side length C. A and B are not given. So what I need to find is, again, here's my fancy hand highlighting. I need to look for B. I need to look for A and lowercase b. So notice I've been given 3 out of the 6 specific pieces as far as measurements go for a triangle, and I need to find the other 3 missing ones. Okay, so that's what we're going to do right here. So the first thing I want you guys to always recognize that if you're given 2 angles right off the bat, go ahead and find third angle. Why? Why do I encourage you to do that first? Well, hopefully you're noticing that you are not noticing, recalling from geometry that the sum of angles of a triangle should always be 180 degrees. Angle A plus B plus C has to be 180. I already have 2 of the angles, so if I want to find angle B, all I'm going to do is I'm going to add these 2 angles, and that answer subtracted from 180, and that will give me the answer that I need. So when I add 56 plus 41 and subtract it from 180, you should end up with angle B having a degree of 83 degrees. So there is my first one. Okay, so I'm going to put my answer up here next to my question mark so that I know that I figured that answer out already. Now let's proceed to find lowercase a and lowercase b. Lowercase a and lowercase b do need to rely on the law of sines to work it out. So you can either use the left side proportion or the right hand side proportion. I tend to use the right hand side more, but use whatever you feel comfortable with, okay? So let's set this up. If I am looking for side A is in my denominator over here, so I know for a fact that I'm going to have to use this rational right now, okay? Because if I'm looking for little a, I need to write down this entire fraction. So I hope I have angle A, which I do. it's 56 degrees. So I'm going to substitute. So I'm going to put here that I'm applying law of sines in your notes. Okay. So I'm going to write sine of, goodness, sine of 56 degrees. And I'm going to put it over lowercase a. And then I have to decide which one of these fractions am I going to set it equal to, okay? Well, if I use sine b over b, I'm going to put sine 83 over lowercase b, and I already have an unknown, so I can't do that one. So I'm going to choose sine c over c. I'm always going to want to choose the one that I already know. So sine c is sine of 41 degrees, and lowercase c is 12 units long. Okay, so when you guys have proportions, okay, notice that these are proportions. We are going to solve by cross multiplying first. And you can't, oh yeah, you can see what I'm writing. Solve by cross multiplying. So I'm going to do this just to give you a visual aid, okay? But I am going to cross multiply over that equal sign. So I'm pairing up this x of sorts. That's why it's called a cross, like an x cross, okay? So I usually, between the two pairs, I usually start off writing the pair that actually has the variable in it, because I like to have the variable on the left side of my equal sign. So a times sine 41 is just written as a sine of 41 all together, next to each other side by side, because in math, two terms that are side by side means multiplication. But if you prefer and you want to put parentheses around for sine 41, go right ahead. Then I'm going to do the other one, 12 and sine 56. And so I'll write it like this. Now, one thing I'm going to tell you is that make sure when you guys are writing these out that you always put the side length in front of the trig function that involves your angle measure, okay? So always put your side length as the coefficient. Now, I am solving for a, so I'm going to highlight this. So that means I need to get rid of sine 41. Well, these two terms are multiplying, so I need to divide both sides by sine of 41 degrees. Whatever I do on the left, I must do on the right. And in so doing, I am able to cancel out sine 41 over 41 because it becomes a 1. And I have solved for a. So let the calculator do the heavy lifting of calculating that answer. So get your calculator. And the first thing you want to make sure is that your calculator is in degree mode. So if you go right here to your mode button, if you have a TI-84, press the mode button, and I need you to make sure that your graphing calculator or scientific calculator is set to degree mode, because every single one of our angles are in degrees. Once that has been established, I need you to come back over here. Again, using a TI-84, I can pull a stacked fraction. What I mean by that is I press alpha y equals, and the first option is a numerator over a denominator. So if I hit enter on that, it creates a stacked fraction. So I will merely type what I have on my paper, and my answer will come up. Now, why is my answer looking different? Oh, I hope you noticed what I did. I forgot to put a 12. I was like, wait a minute, my answer does not look like what it's supposed to look like. There we go. So 15.1639 and so forth. If we're rounding to 2 decimal places, we will just write a 16 because the 3 is less than 5. Again, if you don't have a stacked fraction format on your calculator, notice that all you have to do is just type it horizontally, and you will still get the same answer. So what I want you to do at this point is I want you to pause this video, and I want you to take the time to solve for side length B. Okay, so pause the video and solve for side length B. Okay, so be ready because I'm going to show you the answer so you can check your work. Okay, so notice that B is 18.15, and then what I want you to recognize here is that possibly you may have not used the same setup in proportion, but you still got the answer to be 18.15. I do want to recommend though, when you guys are doing these problems, always try and use the fraction combination of the values that were given to you originally, okay? So what I'm saying is, what if the student had used sine of 83 over, instead of 12, they used, no, I'm sorry, you're looking for B. So sine of 83 over B is on this side. What if you had used sine of 56 degrees here over the A value of 15.16 that you just found? You will notice that you will still get this answer, but what I recommend is that you always use what is originally given to you, because if you had made a mistake here on accident and got the wrong A, when you put your A value here in this fraction, you're going to end up forcing the B to be wrong as well because it was dependent on another wrong answer. So always use what's originally given in your problem. Let's proceed to do quickly example number 2. And actually, I take that back. I want you to work out example number 2. I need you to pause this video because the next time you hit play again, it will show you the entire answer worked out. The entire example 2 worked out. So go ahead and pause, and I'll see you in a couple of minutes. Okay, so here we are with all the work. But let's talk about this triangle before you look at this work. But I'm sure you're still going ahead and checking your answers. So we have a triangle ABC, and they gave us angle 76 for angle A. So I'm going to highlight this. They gave us angle B, which is 21. So I'm going to highlight this. And then they gave us A is 34, and we see lowercase a always has to be across from the capital letter 1. So here's our lowercase a. So notice that what was given to us here was an angle, another angle that's highlighted, and a side length that was highlighted. So the classification for this example 2 problem was an angle side problem, just like example number 1. So again, that's why we are able to use law of sines in this problem. Okay, so I do need you guys to make sure you know how to classify, because when I mix up the law of sines and the law of cosines, you'll have to know how to differentiate. Okay, so again, 2 angles were given. So the first thing was to find the third angle by adding them and subtracting them from 180. So you got 83. And then you did your cross multiplication to isolate your B and your C. And so hopefully right now you are catching on that whatever the letter is paired up with, you will always be able to divide by that trig function that it's paired up with. So those two go in the numerator, you divide by the trig function that's with the letter B. Those two go together, you're dividing by the trig function that goes with the C. Okay, so again, we're going to move on to the next problem, and I'm going to want you to work this problem out as well. But if you would take the time to draw out the sketch of this problem as well. Okay, sorry, I'm should have paused my video there before switching pages. Example 3, I want you to pause the video and work this one out. But over here on the left-hand side, provide yourself a little sketch and do the classification. All right, so pause right now. And the next time you unpause, you are going to see the fully worked out problem, okay? So try this out on your own. All right, so you're about to see the problem, so make sure you're ready. Here goes. Okay, so here is the fully worked out problem. So they gave us a triangle ABC with 3 pieces. We needed to go find the other 3 missing pieces. But again, here's our sketch. Okay, so you will always sketch, highlight what you've been given. So I was given an angle B, and I was given an angle C, and I was given a lowercase a. So if this is my angle A, lowercase a is over here, and so I'm going to highlight this. So they gave me an angle, so this is me classifying. They gave me an angle, they gave me a side length, and they gave me an angle. This is an example of an angle side angle problem. Okay, so the classification, I guess I'll write it here again. Classify, ugh, that Y looks horrible, is angle side angle, which allows us to use law of sines. Okay, now of course right now you know you're not using law of cosines because you haven't been taught that, but this is how you will sort it out. So I want you to notice the difference between angle side angle and angle angle side. Notice that your angles are right here, and your side length that was given is trapped in between the 2 angles. See the shading, angle, angle, and the side length is trapped in between these 2 letters that are capital. But if you look back at example number 1, for example, notice that your angle and angle is right over here, and what's highlighted is a side length way over here. It's not highlighted like here in between. Like if it was an angle side angle, the B would be highlighted. So angle angle side is when the side is not trapped in between the 2. Same thing over here with this one. Notice that your angle and angle are highlighted, but your side length is not trapped here in between those 2 angles. So that's the difference between angle angle side classification, angle angle side classification. The side is sitting on the outside of your 2 angles, but when you look at angle side angle, notice that your side length is trapped in between the 2 angles. Okay, moving on. I know it's a funky order that I'm going to do, but we're going to skip number 4 for now, and I want you to move on to example 5. Okay, example 5 is also another problem that I want you to attempt on your own. We are going to read it together first. So first of all, we have a pole that tilts toward the sun at an 8-degree angle from the vertical. So right over here, very small print, it's kind of hard, is the 8-degree angle, and it's measuring from here to here. This is the vertical, and it casts a 20-foot shadow, so the shadow is across the highway here. Okay, the angle of elevation from the tip of the shadow all the way to the top of the pole is 43 degrees. So your eyesight elevation means your eyesight goes up, so that's 43 degrees. And they want us to figure out what is the length of the pole. So we're looking for little a in this picture, because that's the length of the pole. So using this picture right here, I want you to pause the video and figure out what the length of that pole is. And what I'll do here, if you need a bigger picture, if I can straighten this out well, I'm going to zoom in a little bit just in case you don't have your own copy. Okay, so here is the picture of this story problem. I need you to go find the length of A. So pause your video and go find the length of A. Okay, so if you have unpaused at this point, you are getting ready to see the fully worked out problem. Here goes. So look at this problem. Okay, notice that we were given angle A to be 43 degrees. So over here, I'm going to highlight. It's going to probably rub off a little bit. They gave us 43 degrees, so I'm going to put a capital A. They also gave us this 22 feet, so I'm going to highlight that. Hopefully you can still see it. 22 feet is a side length, so I'm going to put an S right next to that. And then they gave us this 8 degrees, but we were supposed to recognize that that 8 degrees was to the left of this vertical, which forms a 90-degree angle. So to figure out this entire angle right here, which is known as angle B, we had to add the 90 plus the 8 to get angle B. So they ended up giving us this angle, which is another A. So the classification for this example here would have been an angle side angle classification, because notice how the S is trapped between the two angles. And that tells us that we can have permission to do law of sines. Okay, so the first thing, as usual, find that missing angle. So added up the two angles we knew and subtracted it from 180, and angle C turned out to be 39 degrees. So we found that. That was not what we were looking for. We were looking for angle A. We don't care about side, not angle A, sorry, side A. We don't care about side B. So notice how I've only highlighted what I was looking for. All right, now I did have to find the angle to help me find side A, because then it will be too many unknowns. All right, so you need to at least have 4 of them to proceed, you know, so 1, 2, 3, 4, sorry, 4, 1, 2, 3, 4 to get going, because you have 1, 2, 3, 4 slots that you need to fill, and you can only have 1 missing. So anyway, what do we do to solve for A? Well, we know that we have to pair these two up in our proportion, because I'm looking for A, so I did sine of 43 degrees over little a because I'm looking for it, so I paired these two up. And now I have to decide, am I going to pair up the B's over here, or am I going to pair up the C's over here? Well, the C's were the ones that had both of them filled out, so that's why I paired them up. You always divide by the one with the letter, okay, that you're looking for. So I'm solving for A, so sine 39 is what I'm dividing by. Those two go in the numerator. So 23.84 feet was the length of that pole. How tall is that pole? That is the answer. So let's proceed to do this last problem. Okay, so bear in mind that this problem is a bit of work. Okay, but the good news is the first half of the problem is done just as you always have worked out this problem. So what I want you to do is, first of all, notice here what is given to me. Okay, so I've been given a 30 degree, so I'm going to highlight this vertex. I've been given a number 10. I'm going to highlight that. Well, you can have highlighted 30 degrees too if you prefer. Actually, let's do that. Let's highlight what was given to us. Let me do that instead. And let us highlight the 8. And what do these numbers represent? Well, it represents an angle, a side, and a side. Okay, so if you notice, you have an angle side, which usually we don't do it that way. We go in this direction, side, side angle. You will notice that, flipping this over to your essential question area, that's the third classification that we haven't worked with, the side, side angle. And I left the best for last, and I'm saying that sarcastically, okay? This is called the ambiguous case, okay? The SSA is the ambiguous case problem, and that's the one that kind of causes students to get a little bit annoyed. That's my best drawing ever, isn't it? All right, so let's get to it. What I want you guys to do is pause the video again, and I'm going to give you another opportunity to work this problem out just like you always have done for examples 1, 2, and 3, and 5. Okay? And then I'll tell you what it is that you have to do from that point on. So pause the video, and you work on your paper, and I'll work on mine. Okay? So here is this problem partially worked out. Compare what I have on my paper to yours. So possibly you decided to play the video because you got stuck up to this point. And if you were able to continue, congratulations. Excellent work. So notice here we were given 30, 8, and 10. And what we are needing to look for is angle B, angle C, and lowercase b. So what do we need to do? Well, we know that we want to look for either angle B, angle C, or lowercase b. Which one do we need to start off with? Well, both b's were missing, so we were given A, so we definitely picked that as one of our fractions setup. Setting up B right here would have given us two unknowns, so the best option was to choose the C combination. So angle C, sine angle C, is blank over the little lowercase c, which is 10. You're still going to do your cross multiplication. Since this pair here has my letter, my unknown, I'm going to write this one first. You're still writing the 8, the side length, in front of your trig function. And then the 10 sine 30 will go right here. Okay. You are still going to divide both sides by a number, but notice now this time you are solving for an angle. So this is where things changed up a bit. But let's get rid of the 8 on both sides first. Okay. So this 8 and this 8 will disappear. And now I'm left with sine of angle C equals 10 sine 30 degrees over 8. Okay, so don't put that in your calculator just yet, okay? Because my capital C is not isolated. I need to get rid of sine. So if you recall from last semester, what you're going to do is, in essence, let's pretend we can actually say this, but you can't, that you're moving the sine over to the other side, okay? That's not really the case. But what you're doing is you need to get rid of this sign by taking the sine inverse of both sides. So the capital C will only be isolated when you take the sine inverse on both sides. And so I'm taking the sine inverse, or the arc sine, of 10 sine 30 over 8. And you will type that entire thing in one shot. Okay, so let's put on our calculators. I'm going to do alpha y equals 10 times the sine of 30 divided by 8. And, oh goodness, I forgot to put sine inverse, so let me erase that again. Sine inverse is right over here, above the sine button, sine inverse. So sine inverse, or arc sine, then let's do alpha y equals 10 times the sine of 30 divided by 8. Let's hit enter. and we get 38.68 degrees. So where can I write that? Trying to let you be able to see it. So I'm going to come over here. Capital C is 38.68 degrees. Now, with ambiguous cases, okay, if you end up with no, like if you end up when typing this out with an error message, okay, so if you get an error message, you are going to tell me that this problem is a no solution problem, okay? So if you get an error message after taking the sine inverse of some fraction right here, it's a no solution problem. And what you're going to do is there's a minus button in Delta Math that you would have to press, but what's going to end up happening is it ends up giving you like a little set notation like this. That's called a null set. So if you end up doing a problem on Delta Math that ends up being no solution, press the little minus button on the upper, like towards the right of the answer box. There's a little minus button, and when you hit the minus button, this is going to pop up, and that was what you will write your answer, okay? But in this problem, this is not a no solution problem because we actually got an answer for angle C. So I'm going to come over here and write 38.68 in for my angle. And now that I have these two, I can find angle B by subtracting the sum of 30 plus 38.68 from 180. And when I do that, I get 111.32 degrees. Whoops. So this one here becomes 111.32 degrees. Okay, so this is the second answer that I have. Now that I have almost all of them, I'm able to find lowercase b. So if I'm looking for lowercase b, I've got to use the fraction that has the b values in it. So sine of 111.32 degrees over lowercase b, which is what I'm looking for, equals, so am I going to use the A combination or am I going to use the C combination? I always suggest that you use the combination that is given to you. So since this was given to me in the original problem, that's the one I'm going to use. So sine of 30 over 8. So in cross multiplication, the b is paired up with sine 30, so I know this is going to go in the numerator. So b equals 8 sine of 111.32 over the sine 30, which is with the b. And when you put all of that into the calculator, you're going to get a b value that is worth 14.91. So you would think that that's where your problem ends, right? Well, that's not the case. So digest this first before I tell you what it is that we need to do next. So pause your video and make sure you understand everything up to this point. Okay, so if you have a grasp of what is going on in this problem, here's what I need you to do, all right? When you have an ambiguous problem, so let me label over here on the side, for example, 4, that this is an SSA problem, okay? And it is what we call the ambiguous problem, okay? I like to call it the pain in my tail type of problem. Notice if you spell this backwards. Yeah, it is a tough problem. Well, not a tough, it's a tedious problem. So once you have figured out what you've always done and figured out how to solve the problem. Your question is this the only triangle, or is there an additional triangle? So with ambiguous problem, you're either going to have a no solution result, you'll have a one triangle result, or it will end up being a two triangle result. Okay, so what you're going to end up doing is trying to see if it is a two triangle, because it definitely was not a no solution, because when you took the inverse to find the angle, it worked. Okay, so if it works, you know for sure that there is at least one triangle. Your job now is to check and see if there's actually two triangles that exist with these scenario values. Okay, so how do you do that? What you're going to do is always go back to where you found the first angle. Okay, remember you were only given one angle, and it was angle 30, and then you proceeded to find the next given angle, and when you did so, you found angle C to be 3868. So this was the first angle you found, not this one, okay? So angle C is 3868. But the question is, so I put a star here, I'm going to come over here. The question is there another possible C angle measure? Okay, that's the question you're asking yourself. Is there another possible C angle measure? And you only ask this question for yourself when you do the SSA problems, okay? So, how do I decide that, okay? Well, you are going to find its supplement angle. And if you recall from geometry, the supplement angle is always an angle that are two angles that add to 180. Okay, so if I need to find the supplement of 38.68, I'm asking you to find the angle that when added to this number will equal 180. So all I have to do is say, well, if I'm looking for another C value, I'm going to put another question mark here because that's another C. I need to do 180 minus 3868. Okay, and it's always going to be 180 because 180 is supplement. I'm going to move this ASA over. I'm going to put it right over here. And when you take 180 minus 38.68, you are going to get 141.32. Okay, so right now our angle, our first triangle has angle C of 38.68. Our other triangle has an angle of 141.32. So for now, we have a question mark. We're like, okay, maybe that's an answer. Let's see if we can find B. Well, let's find B. Well, B was found over here by doing 180 minus the sum of 30 plus 3868, okay? Because we're doing 30 from this angle, and we had to add the 3868 with this C. But now we're saying our C is this one. So let's do 180 minus the 30 plus our new angle C, 141.32. And if we do that, hopefully we get an angle. So if you add 30 plus 141.32 and subtract it from 180, the angle we get is a positive angle, so B does exist. So we put 8.68 degrees. If this does not exist, in other words, you end up with a negative angle, then you stop and you can't go any further. So that means if you can't go any further, you can't proceed to find a lowercase b. So you're done. There's only one triangle. But since it worked here, that means we still keep going with the same process we had over here. Okay? So instead of using sine of 1/1132, because that was the b for the first triangle, the b for the second triangle is working. So let's do this fraction or proportion. Sine of 8.68, which is the new b, over lowercase b, equals the sine 30 over 8 never changes because that was given from the beginning. And when you cross multiply and solve for b, b is going to equal those two numbers divided by the sine 30 that's with the b. And when you divide both of those values, you end up with b equals 2.41. Oops, you can't see my 1. Okay, that looks horrible. So in essence, what you're telling me is that the solution to this triangle is that it has two possible triangles as an answer. The first triangle can have an angle of 30 degrees for A, 111.32 degrees for B, 38.67, 8 for C, A is 8. Where was my B? My B was 14.91, and my C was 10. But then they're coming along and saying, hey, you actually have another possibility of an answer. So instead of 111.32, they're saying your B can possibly be 868. Instead of 38.68, your C value can be 141.32. Instead of 1491 for lowercase b, it can possibly be 2.41. So those are your two triangles for example 4. Okay, so repeating myself with the no solution, if when you do the first arc sine, you end up with an error message, you just say no solution and you are done. You do not do any more work. If you do get an answer, work it out like you've always been working out and you found your first answer, your first triangle. But if you find a first triangle in an SSA problem, you have to go check and see if a second triangle exists. So that means taking the angle you found, the first angle, and subtracting it from 180 and using that as a possible new angle. And then repeat what you did here with the new angle and see if you get values that make sense. If you get an error message, just stop. You don't have to find a second triangle anymore because you got an error message, and that just means that you only ended up with one. If you do not get an error, that means you ended up finding the other three answers, and so those did work because error messages did not pop up. So 1, 2, 3, 1, 2, 3, two triangles. Thanks for watching. If you have any questions, let me know.